Hannah?
Hannah.
Hannah? Okay. So the whole point of our table here is to talk a little bit about buoyancy and density. What we're kind of trying to discuss between these experiments is why an object will flow like this and when an object will sink, right? So we have two very interesting experiments right here. We have this one where we have a lure inside a bottle filled with water, right? This is like a fishing lure. Do you know what a fishing lure is? Yeah? Okay, so try squeezing on the bottle and look what happens. It sinks, right? Yeah, try one more time. So do you have a guess of why it sinks when you squeeze it? When you what? So actually inside this lure it's like this, where you have a space where it's all water and there's a space where it's actually air. And when you push on this bottle, you're actually forcing the air to push in more water. Yeah, so then by pushing more water in, the lure gets heavier, right? Yeah, so then it's going to be heavier and heavier until it's going to sink. Yeah, right? Okay, so then now we move on to this experiment. And you see how the beads are exactly in the center of the bottle? Isn't that kind of weird? Haven't you learned that objects, when you put them in water, yeah, it's either going to be on the top or it's going to be on the bottom, right? So how come this is exactly in the middle? Any guesses? No? Okay, so actually the trick is that there's two different liquids inside. They're not the same exact liquid. This is water and this is alcohol. So then they have different densities because they're different materials, right? So that's why the beads are more dense than the alcohol on top, so that's why they sink. But then they're they're less dense than the water on the bottom. So then they have a density right in between these two. And then, so that's why they line up along the middle.
You see it?
You see it?
Yeah.
So
That's neat.
let me shake up the bottle now.
Okay.
And do you see what happens? Look what happens. How come the beads are separated now?
Different density then.
Right? So that means the beads have different densities themselves too. So there's actually 4 different densities inside this one bottle. There's the
alcohol,
density
the water,
of
and the
the
two
alcohol.
beads.
Yeah, the 2 different beads and then the water. And that's how we get this little middle layer of beads.
That's
It's actually
interesting.
very similar to the experiment where you have 4 different colored liquids in a
Okay.
test tube, and you shake them,
And
then
they
eventually separate out into different
Oh,
layers.
yeah.
Except instead of 2 of the layers, we're using beads now.
Okay, now let me ask you, if she ever did something like that for science in her class, what type of liquid would she use to get 4 different liquids in a tier?
Great question.
Yeah, that's actually a great question. Usually water would be one of them.
Okay.
And then you know that,
And water would be one color.
yeah, water would be one color.
Okay.
And then you get maybe oil,
Oil, okay.
and then that would be like have a tint of a yellowish kind of
Okay.
color. And then you would have maybe an alcohol.
Alcohol based,
Yeah,
okay.
and then if you wanted to, you could have a starch or something like that and mix it in liquid form.
Okay.
And then that would have a different
So
density
we
than
have
the other.
oil would probably sink to the bottom, I guess. and then-
Actually, oil would be on the weight. Would be near the top. Because
Oh, okay.
water would be probably near the bottom.
Actually, oil is thicker because it's more viscous, but it's actually lighter than water.
That's
Yeah.
interesting.
And if you
It's
want it to
really
be really, really cool, you put mercury in there, which is a liquid
Yeah,
at room temperature,
yeah.
and that
Yeah.
would go
I'd love
straight
to go
to
to
the
school and
bottom.
admit that, yeah. Okay,
By
great.
the way, do you know where the information booth is?
Oh, excuse me.
I have.
Oh, hi there.
So there's actually one more experiment if any of you guys
Hey,
are
that's
interested in
interesting.
it. So inside